Hello everyone and welcome. In this lesson, we are going to be looking at the junction side distance. What's side distance? So we normally have side triangles that are included. And mainly, we look at side triangles from two perspectives. There's A1, the approach side triangles, and there's the departure side triangles. So departure is their leaving, approach is their coming. And these are the two we are looking at. So when we are approaching, just a quick question. Where do you think we take the side triangles? Do we take them at the start? That is to say, D1. Do we take them at D2? Do we take them at D3? Do we take them throughout? Or do we take them exactly at the junction? And what values do we use? Now that's what we're going to look at. So, what's the first decision for side? What are the approach distance we're going to look at? So one of the approach distances we're going to look at is we are on a minor road. Remember I talked about a major road and a minor road. So we are on a minor road. Now picture yourself, you are on a minor road. You need some distance. For example, there's a car on the major road. So on the minor road, we are going to have a distance we call A1. And you may be asking, what is A1? So we have a distance called A1, and we are trying to ask ourselves what's A1. So in this case, you're going to find that it's the distance required to brake in case of an issue. Okay? And we have a second distance, which in this case, you're going to find we're going to call B1. And B1 is the distance required to view the driver on the road within the right-of-way. That's why when we are designing the right-of-way nowadays, okay, you're supposed to design it coming like this, but then curving. The purpose of this right-of-way is to allow for sufficient side distance. You're going to look at some examples where people do not consider this, and the junction becomes a hazard. So you want someone coming from the minor right-of-way, they're at this decision point, and at this decision point, they're able to see the vehicle coming on this other side. Okay, so it can be this side, it can also be on the other side of the junction. Okay, so I'm explaining this from even if you're doing left or right. So what's very important is what's the distance the driver needs to brake. Okay, now if you're ever designing a junction and you're flaring it, so for example, you've done the standard junction design and I'm putting a walkway. I always flare the walkway to allow for that side distance. So if I'm on a minor road, I need to be able to see that. Okay? And we show you how to do this. Okay? So we have the second side distance. What's this one? So in this one, again, we have two parameters, as I mentioned earlier. This is the side distance required for someone who's on a minor road to depart onto a major road. So for example, if someone's coming here and they need to, this is now right-hand drive, okay, in the opposite direction. If someone is on a minor road, in this case to be what distance is required for him to depart onto that. If you're now driving on the left-hand side, I've drawn two arrows to explain. So first is the distance to brake. Then what distance does he need to depart? This is the second distance that we are looking at in terms of side distance. These are issues you have to consider, okay? And you can see how we always measure it. It's a small envelope. Now you may find that your first distance maybe went something like this, and now your second distance adds a smaller envelope. And you may find that you need all this kind of side distance to make sure your junction is safe. So we shall see how we do that. So we have intersection control cases. We have case A, case B, case C, case D, case E, case F, and case G. We go through these trying to explain, okay? So if you have, let's say, case A, where you have no intersection control, there is nothing. So what are some of the considerations you can make, okay? You shall find that they are going to recommend, if you're designing 50 kilometers per hour, or 30, they're going to recommend 140 feet or 45 meters. So from the junction, they're going to recommend the length of the leg to be 45 meters. Okay, so make sure at least you have that side distance for 45 meters. If you're designing for it to be 30 meters, make sure you have 25 meters or 115 feet. Now, if the junction is located on a grade, so for example, you cannot treat a junction located on a 6% grade the same as a 1% grade. So you're going to have something we call an adjustment factor. So if the junction is 25 miles per hour, for example, on the other one, you're going to have an adjustment factor. So for example, in this case, you would multiply your distance by 1.1. So for example, if you go to 45 meters, multiply it by 1.1. The grade always influences this distance. It was very important for you to understand, one, the side distance needed on the minor road to see the car on the major road, and also the departure into that. So that's case A. There's no intersection control. What distance are you going to look at? So we have a second case where we have a stop. So someone is always told stop, whether this or that. And then what do we consider in this case? Okay, so what you're looking at is, this is a left turn from a minor. Okay, remember what I'm showing here is if someone's driving on the right hand side. So if someone's driving on the left hand side, this would be right. Okay, so if you're driving on the left hand side, this would be right. If you're driving on the right hand side, this would be left. Because in my country we drive on the left hand side, it's a right. So you know what happens with the right. Traffic is turning right, like for example in this case. Okay, but this is a signalized control, but we're assuming you're on a minor control. What are the things you should consider? So they're giving intersection side distance. So in this case, you could consider a distance of roughly, in this case, 62 meters or 104 meters to allow someone to have that sufficient side distance. Because remember, they have to be able to see the other car and they need to be able to brake. So we have a second case, and the second case is a right turn. And again, if you're driving on the left-hand side, it's a left turn. And again, it's the same, but you're looking at minor. Now, this third case is crossing the major road from a minor. Again, this is the same. You take from the same point going downwards. So for example, if you're now calculating the side distance on the major road looking at the minor, you can also do the similar calculation on the side distance. So just to put this into perspective a bit, this is our minor road. You look at this side distance and you say, okay, how far back am I seeing here? How far back am I seeing? Okay, so you first calculate this distance. If let's say you're doing a left turn, for people who are driving on the right hand side, you are looking at something like this. Okay, so you are going to, in this case, because you're trying to look at a vehicle turning right. Okay, so you're trying to look at vehicles that are going to oppose traffic in that direction. Now for me, if it's a left turn, my main worry would be a vehicle coming, let's say in green, a vehicle coming from here. Your worry is, if I'm turning, let's say left turn, do I have enough space to be able to see this vehicle that's coming? Also, if you're here, you're on the major and you're going to turn into this road, do I have enough sufficient distance to see? And that's the case we're talking about right now. This is the case B. Now, case C is you have a yield sign. And again, these are the same. These are just values to help you understand. If you understand how we move C1, C2, C3, this is the case with a yield sign. CD is the case with a signal control. And again, we ensure to make sure that cars have sufficient side distance. Now, something I just want to show you here is we can just turn on vehicle tracking and we can just simulate a vehicle, okay? So I'm going to just simulate a large vehicle. In this case, I always use length. So click this to sort by vehicle category and to also sort by length. So I'm going to use WB19. Okay. And I'm going to just simulate the vehicle in this case. So you would be able always untick this, turn on left hand and move. So we can put the vehicle here and we say, okay, I'm simulating the vehicle, proceed, and I'm going to put a speed of 50 kilometers per hour, which would be 30 miles. Let me make this 30 because the cars which are turning, most of them can be at 30. So then you come, and again, I'm just trying to check how good my stopping side distance is. You can see in this junction, the junction had to be widened to accommodate, okay, the vehicles, okay, the large turn vehicles. You can see it's not touching anything, okay. That's why there's a wide shoulder there, as you're saying, okay. So then the vehicle now can come back and move into the junction. Now that's why if you look at this junction, while we are starting to see this is a green belt and the walkways are all the way this side, you can see that the lane was wide enough. You can see how wide the lane was. In this case, this lane is 6 meters wide, which can be roughly around 20 feet. But you see, we had to add another shoulder, roughly of 2 meters, which is roughly around 6 to 7 feet, to just allow that vehicle to turn. Now, when you click on vehicle tracking and you go to swept parts and you go to place outline and you click this and it places the outline on the vehicle, there's something called visibility sightlines. Turn it on. And what happens is you can see these sightlines that are happening, okay? Which I feel is very good, important consideration when you're doing junction design. So again, if there's a signal control case D, right turns are not, in case right turns are to move on red, use case B2. So again, here I'm just detailing what you should use. Signal cases with all stop, these are pretty standard. You use what we have for case D, but you can have two-way flashing and a right turn. Now, there are cases where you have a signal with a yield. At signalizing intersections where the first vehicle stopped on one approach should be visible to the driver of the first vehicle stopped on each of the other approaches. What do you consider? Left turn from the major, which is basically right turn from the major road going. What are the considerations you should have? Now, what is the effect of a skew? As I mentioned earlier, what you have here is it increases the sight distance. And this is why you want to avoid these tight angles. You can see you have to calculate the angle and you do a sine. For example, here you see we're trying to get the new sight distance because we have to establish. You can see the sight line. Okay, you need this, and so you can see how farther back. So when your junction is skewed, you need further sight distance, which may not be the wisest. So when you're designing these junctions, make sure you keep to 90 degrees. Worst case, 75 degrees. So I hope this gave you a very good brief introduction to junction design in terms of the theory. When we are designing the junctions, I'm going to be referring back to most of this. I'm going to be bringing you back to the theory. So I'm hoping in week 2, while we look at nexus and we start to draw out these junctions, you're ready. Otherwise, thank you for your attention on week 1, and I hope to see you in the next lesson.